All right, let's dive into a technical mystery that could completely blow the doors off Formula One in 2026. It all starts with a rumor, a whisper coming out of the most secretive places in motorsport, the engine development rooms. And at the absolute heart of all this buzz is a number that seems, well, kind of small, just 13 horsepower. In a sport with 1,000 horsepower beasts, you might think, so what? It's a tiny gain, but it's one that powerhouse teams like Mercedes and Red Bull powertrains are rumored to have already found for their new 2026 engines. So this is the puzzle that's got the entire F1 paddock completely obsessed. How can a power gain that's barely more than 1% of the total output somehow be worth a jaw-dropping 0.4 of a second every single lap? Now, in Formula One, that's not just a small step forward. That is a giant race-winning, championship-deciding leap. And today, we're going to put on our detective hats and solve this thing. So how on earth do we get from 13 horsepower to nearly half a second of pure performance? Here's how we're going to break it all down. We'll start with the rule that opened the door, then look at the genius engineering that kicked it wide open. From there, we'll see how that tiny gain gets multiplied, creating a massive strategic advantage. And then we'll wrap it all up. First up, a rule and a loophole. Because you see, to understand this brilliant solution, you first have to understand the brand new playground the engineers get to play in for 2026. The whole game has changed. Okay, so the big headlines for 2026 are pretty major. We're going to a 50-50 power split, half from the traditional engine, half from the electric motor. Plus, we're moving to 100% sustainable fuels, which is fantastic. But for our mystery, the two most important rules are these. First, they're now limiting the total energy you can get from the fuel, not just how fast it flows. And second, and this is the big one, they're forcing the engine's compression ratio down to a maximum of 16:1. But you know how F1 engineers are, right? They live for the fine print. And buried deep inside the technical regulations are 4 little words that change everything. Executed at ambient temperature. All that means is the engine only has to follow that 16:1 rule when it's cold, sitting still in the garage. And right there, that's the loophole. It's brilliant. The rules define the engine's specs in one very specific state: cold. But an F1 engine doesn't race cold, does it? No. It operates with its guts screaming at over 250 degrees Celsius. And on that crucial hot racing state, the rulebook says absolutely nothing. Total silence. So, how did some of these smartest minds in motorsport allegedly exploit that silence? Well, the answer comes from something you learned in high school physics: thermal expansion. But this is thermal expansion applied with unbelievable, mind-bending precision. Okay, check out how clever this is. When the engine is cold, the FIA inspectors measure it, and yep, it's a perfectly legal 16:1. But then it gets out on track and heats up. And this is the magic trick. The internal parts, things like the titanium connecting rods and aluminum pistons, have been designed to expand at a specific rate. This expansion physically pushes the piston just a little bit higher inside the cylinder, which makes the combustion chamber smaller, and just like that, its dynamic compression ratio, the one that matters when it's racing, becomes a much more powerful 18:1. And when I say a little bit higher, I mean it. The entire assembly of moving parts is designed to grow vertically by just 0.42 millimeters more than the engine block around it. That's about the thickness of 4 sheets of paper. It's an absolutely incredible feat of material science. You see, this is why that 13 horsepower number isn't just a rumor. It's not a guess. It's straight up thermodynamics. If you take an engine with a fixed energy input and you increase its compression ratio from 16:1 to 18:1, you will get exactly that much more power. It's a direct result of making the engine more efficient at turning heat into force. Okay, so we've found our 13 horsepower. Mystery solved, right? No way. Not even close. Now we get to the real heart of this, the part that explains the massive lap time. And the answer has a name that every F1 driver dreads: clipping. So what is clipping? It's when that massive 470 horsepower electric boost just runs out of juice for the lap. When that happens, your acceleration doesn't just dip, it falls off a cliff. It feels like you've slammed on the brakes, and it absolutely murders your lap time. And here's the fundamental problem baked into the 2026 regulations. The battery gives you enough energy for about 11 seconds of that full electric boost. But on a power-hungry track like Spa, you can be at full throttle for over a minute. The math is just brutal. There is not enough electrical energy to go around. So the key thing to understand is this: Every single car on the grid will be forced to clip. The race isn't about avoiding it, the race is about who can put it off the longest. And this, right here, is where our little 13 horsepower becomes a giant killer. Because that loophole engine is more efficient, it needs less help from the electric motor to keep screaming down the straights. That means for every second you're flat out, you are just sipping from the battery, while your competitors are chugging it down. So you have to think about it this way. That 13 horsepower isn't the weapon itself. It's the lever. It's the small, clever gain in efficiency that lets a team use the real weapon, that massive 470 horsepower electric motor, for longer than anybody else. You're not just buying power, you're buying time. So let's take this out of the dyno room and put it on the track. How does this engineering trick create such a devastating advantage in a wheel-to-wheel race? Well, for the teams who haven't figured this out, it leads to a nightmare scenario they're calling the strategic spiral of death. Imagine you're in a car with the standard, less efficient engine. To just keep up with the car in front down a long straight, you have to burn more of your precious battery energy. You're constantly on the back foot, just trying to stay in the tow. And this means you arrive at the end of the straight, at the key overtaking point, with less energy in the tank. This creates a huge power imbalance. The car with the loophole engine has been cruising, saving energy. It arrives at the braking zone with a full battery, ready to attack or defend. The car with the standard engine, it's already running on fumes. It has nothing left to fight with. It can't attack and it can't defend. It's a total sitting duck. Okay, let's tie this all together. Let's trace the entire chain reaction. From one clever reading of the rules, all the way to a potentially championship-winning advantage on the track. So here's the whole story. It starts with using thermal expansion to dynamically raise the engine's compression ratio from the legal 16:1 to an operating 18:1. That simple change creates about 13 extra horsepower. That extra power from the engine itself means you rely less on the electric motor. By conserving that precious electrical energy, you can delay the point of clipping, extending that 470 horsepower boost further down the straights than anyone else. And that extended boost is what delivers the incredible 0.4 of a second advantage. And that brings us to the big question, the one that gets right to the soul of what Formula One is all about. The FIA wrote a rule with one intention, and a handful of teams, using their absolute mastery of physics and materials, found a genius way around it. So what do you think? Is this a cynical violation of the spirit of the rules? Or is it exactly the kind of brilliant, ruthless engineering that has always defined the absolute pinnacle of motorsport?